Hello, this is my project report 2. I decided to stick with the same subject, materials and structures analysis of solar panels. I'll update the video link here once this is uploaded to YouTube. I did some history, and I'm not going to go over every single bullet point just because this is an update on the project. I'll save most of that for the final report. So just a few of the main points is that solar panels use photovoltaic technology, and the first time that was used to on a larger scale for everyday electrical components was 1954. Popularity has gone up significantly and started to go up in 1980 when the world population really became cognizant of the amount of fossil fuels that we were depleting. The expected pricing of solar panels should be comparable to traditional energy sources within 10 years. So it's been improved vastly since it first was discovered. Some of the background. There are 3 types of solar panels: monocrystalline, polycrystalline, and thin film. For purposes of this project, I'll be focusing on the monocrystalline because it is the most efficient of the 3. Solar panels obviously have to withstand extreme temperatures, winds, sunlight, different humidity, all different areas of the world. The main material used in manufacturing solar panels is silicone, and it comes from quartzite and undergoes quite a few processes to get it to the level of purity that is needed for the panels. To start with the material processing, the quartzite is melted with carbon and is purified using the Siemens process, which is basically heating and cooling several different ways to get to your pure product. So in this case, the powder silicone is exposed in a reactor with hydrochloric acid at high temperatures, and this results in trichlorosilane gas. After that, the gas is cooled and liquefied for distillation. That is then heated and cooled to remove impurities of elements that have higher and lower boiling points. A couple of examples would be calcium and aluminum. This is then, once those impurities are removed by that process, it's moved to a different reactor mixed with hydrogen gas, and then it's vaporized again. And due to the high heat and the exposure to the hydrogen gas, the chlorine atoms will dissolve, and what you're left with is a near 100% pure silicone, 99.99 to 100%. So once you have your highly pure silicone, It's doped with boron, and I'll talk about why in a second. And then it's melted into a single crystalline ingot. So one of the differences between monocrystalline and polycrystalline ingot solar panels is the monocrystalline is only used from one ingot, and the polycrystalline is a bunch of them melted together, so it's not as pure. So once you have your ingot, then they use a wire to thinly slice into wafers. As you see in the fourth little icon here, the silicone wafer, and it's polished. So when you dope the silicone with the boron, you're creating a positive charge, and then after all of this happens, the ingots are placed in a furnace below the silicon melting point, and phosphorus gas is entered into the chamber, and what happens is it absorbs some of the phosphorus gas particles, and then it has the negative charged ions, so what you're getting is the positive negative junction. That is what is conducting the electricity that is needed for the panel to operate properly. So then all of those different cells are soldered together in a structure as you see on the screen, and the front of the panel receives a layer of tempered glass. And the primary purpose of solar panel glass is to transmit as much sunlight as possible into the module. So an anti-reflective coating is applied because it helps reduce the loss of some of that light, and improves transmissivity. The most commonly used anti-reflective coatings are titanium dioxide and silicon oxide. This reflective coating can help increase the percentage of the absorbed sunlight by 2.5% roughly. The glass is actually not a smooth surface, it is a rough surface. It helps the ethylene vinyl acetate film stick to or bond better to the glass. And then you have your aluminum frames for durability. It's typically what is used as aluminum. And then the microstructures, I'm just going to go over the top 3 materials of a solar panel, which are the silicone, the aluminum brackets, and the tempered glass. So as you see here, here's the different microstructure looks: silicone in the top right, aluminum in the middle, and tempered glass on the bottom right. And I will update this with a few more details before the final project report. I needed to do a little bit more research and just update a few details here. So that's all. Again, I didn't go into everything. I will in the final project report. But this is where I'm at. Thanks.